All right, so let's go over this word problem. And as it's mentioned before, initial value, often the y-intercept. The slope is often the rate of change. So to get from one floor to another at a library, you can either take the stairs or the escalator. You can climb the stairs at a rate of 1.75 feet per second, and the escalator rises at a rate of 2 feet per second. You have to travel a vertical distance of 28 feet. The equations model the vertical distance, d in feet, that you have left to travel after t seconds. So d is not how far you've traveled, it's how far you have left to get to wherever you want to be. And then t is how many seconds you've been on the escalator or on the stairs. So the equation for the stairs is d equals negative 1.75 t plus 28. And that's because we are trying to reach a distance of 28 feet. The reason I think they made it kind of backwards is that they didn't want you to start at a distance of 0. So they're doing this backwards, like, oh, you're going to get to 28 feet, and this distance is not distance traveled, but distance to the point. And that's why this is negative, because we're not moving at 1.75 feet forward. We're decreasing the distance we have to go by 1.75 feet every second. I hope that made sense. If not, find me on Google Meet. Escalator, same idea. You got 28 feet to go. You're moving 2 feet per second. So this is the equations. So graph the equations in the same coordinate plane. Both got the same y-intercept. The only difference is the slopes are a little bit different. These slopes are kind of hard to manage. So I'd honestly recommend what they've done here and just find the x-intercept or the t-intercept, as you can see the t-axis here, the t-intercept, and just connect those points as they've done here. So one, the t-intercept is 14. That would be the escalator. It's faster. And the stairs are 16. So you're going to draw the graph of d equals negative 1.75 t plus 28, using the fact that the d-intercept is 28 and the slope is negative 1.75. Similarly, draw the graph of d equals 2t plus 28. The graphs make sense in the first quadrant. So after you find the t-intercept represents how much time it's taken to get to that 0 distance, to get to the destination that you want. So obviously, based on the fact that they're saying that you're going faster on the escalator, you're going to get there faster. So the escalator is going to take 14 seconds to go 28 feet, and the stairs are going to take 16 seconds to go 28 feet. Personally, I think you can go faster on the stairs if you really try, but you may be breaking a sweat by the end, but just my 2 cents. All right. Now, we have a little parallel line. Oh, can I not click this? Oh, what? All right, we'll do this in person. I'm going to go over this lesson again when we get back. But simply, this is one more concept. So 2 lines in the same plane are parallel if they do not intersect. Because slope gives the rate at which lines rise or fall, the two non-vertical lines with the same slope are parallel. So we know that parallel lines are 2 lines that don't intersect, right? Well, using our knowledge of slope, we can say that 2 lines will not intersect if they have the same slope. So we have these 3 lines. We can find the slope given these 2 points. We can also just count up. So rise 1, run 3. So that's a slope of 1/3. Here we got rise 2, run 1, 2, 3, 4, 5. So 2/5. And here we have rise 2, 1, 2, 3, 4, 5, 6. So this is a rise of 2, run of 6. As you can see, they've done the math over here. First one has a slope of 1/3. Second one, slope of 2/5. And the third one has a slope of 2/6, or -2/6, same tomato. And that simplifies to 1/3. So the blue line and the green line are parallel because they have the same slopes. All right, one last